All right, geometry lesson 4.2. This is on reflections. This is our second type of transformation. So now when we are talking about transformations, again, we did translations in 4.1. Now we're doing reflections, and then the next one will be rotations. So again, these are all different ways that images are moving from an image to an image from a pre-image. So again, with reflections, a reflection is a transformation that uses a line like a mirror to reflect a figure. This is called a line of reflection. So on here we have point P is being reflected over line M, so that we have point P prime. Now, when reflected over that, point P is being mapped onto P prime. It is equal distant from that line. So you notice there is a perpendicular line going from P to P prime. It'll always be a perpendicular distance, just like we said, the shortest distance from a point to a line is a perpendicular distance. We're using that perpendicular distance here to reflect across that line. So again, it'll always be a perpendicular distance, and it'll go the exact same distance that it is from that line of reflection to the other side of the line of reflection. Now, if you have a point on the line of reflection, it does not move. It's going to stay exactly where it's at. On example 1 here, reflecting in horizontal and vertical lines. Now, this one, anytime we reflect in a horizontal or vertical line and we're given points, we actually just have the line reflecting in, how can I say this? The points will be changing the x coordinate or the y coordinate just by changing a negative sign, and it's the opposite if it's in the x-axis or the y-axis, whereas if it's being reflected in a line that's not the x-axis or the y-axis, it's going to be shifted however many units away it is from the line given. So again, let's just look at an example and see what we're talking about. For this one, it says we're reflecting in the line y is equal to 1. All right, so we're going to have the points that they gave us to begin with. One of those is at the line y is equal to 1. So we have this triangle. This is our line of reflection. So point C is on the line. Point C will not move. Point A and B will go the exact same distance it is away from that line. So right now it's a horizontal line. So if we go the vertical distance, that'd be the perpendicular distance away. So we're going to take A, which is 2 units above the line, and move it 2 units below the line. So right now, again, 2 units above, going 2 units below. Then for B, we're only 1 unit above. So we're going to go 1 unit below. So we have our 2 new points there, A prime and B prime. Our third point won't be a new point because C is on the line. Since it's on the line, that same point will be C prime. And then we can draw our new figure, which is our image. So we went from A, B, C being our pre-image to A prime, B prime, C prime being our image. Same thing on the next one. Now, this time, x equals 3. This is a vertical line. So this time, instead of moving from top to bottom, we're moving from left to right or right to left. So same image to start, same points, but now we're being reflected over this line. So A is 2 units to the left. We're going to go 2 units to the right. So that's A prime. B is 2 units to the right, so we're going to go 2 units to the left. C is 1 unit to the left, so we're going 1 unit to the right. So now we have A prime, B prime, and C prime, and we have our new diagram. Again, it's a reflection in that line. All right, now reflecting in the line, y is equal to x. So if we have a line that is diagonal, going a positive diagonal with a slope of 1, going through our coordinate plane, our values actually end up switching. So you may remember from algebra that we talked about an inverse function where x and y switch. When you reflect in the line, y is equal to x, it is the inverse. So again, the x and y values are switching. So for this, we start off with our points at -1, 2, and our point at 2, 1. We have our line of reflection, which is that diagonal line with a slope of 1 going through the origin. Now, what's going to happen? Those values are just going to switch. So the x is going to become the y is going to become the x. So we have our original point. Now notice they are doing a perpendicular distance here. So they're showing it in terms of the same thing that we did before, looking at the distance, taking that same distance away. But again, this is a rule that you will need to know. The actual reflection here is going to be just switching the X and Y axis, or sorry, X and Y coordinates. So on here, same thing, they just switched. So notice the new coordinate compared to the old coordinate, same values, just reversed. So if you look at the top one, we had F was at -1, 2, and now we're at 2, -1. For G, it was at 1, 2, so G prime is at 2, 1. So again, they just switched. All right, let me erase that. All right, next. So, next I went backwards for a second there. All right. Now, here are some rules that you need to know. So again, you need to memorize these. I would highly recommend maybe even making an extra index card with these rules on them. We're going to have rules like this for each one of our transformations. Again, it would be beneficial to make sure you know these well and study them. But if we reflect in the x-axis, the y value becomes the opposite sign. So it says a negative b. That doesn't mean that b is negative. It just means that whatever value was there originally, it is changing sign. So if we had a negative number for b, it becomes positive. If we had a positive number for b, it becomes negative. Same thing if we reflect in the y-axis, then it's the x value that is changing sign. If we reflect in the line y is equal to x, then they switch positions. And then if we reflect in the line y is equal to negative x, they switch and become negative, both of them. All right, so those are 4 rules about reflections that you should know. All right, now on this one, this up a little bit. All right, we have reflecting in the line y is equal to negative x. So again, what's happening? Those points are switching and changing signs. So F was at, why isn't this moving? Hold on. F was at -1, 2. So if we reverse it and change the sign, it'll now be at -2, 1. So there's our original on the graph. This is our line we're reflecting in. Again, knowing our properties, we're just switching and changing our signs. So it becomes -2, +1. For G, same thing. We were at 1, 2, so we're going to switch them and change the sign. So 1, 2 becomes -2, +1. Sorry, -2, -1. So we have our 2 points. And if you look at the image, you'll see it is a reflection in that line. And if you want to see the reflection better, you can take your paper and actually turn it so that the line of reflection is vertical. A lot of times, if you're looking at the line of reflection vertical or horizontally, it's going to make it easier to actually see that it is a reflection. All right. The first postulate for this section, the reflection postulate. A reflection is a rigid motion. So we talked all about rigid motion in the last section. A rigid motion, also known as isometry or a congruence transformation. When we have a rigid motion, the image and the pre-image are going to be they're going to be congruent. They're going to have all the same measures. They're going to have all the same lengths. So the angles are the same. The segments are the same. Now, it's not facing the same direction this time. So in a translation, the figure was also facing the same direction. It does not have to face the same direction to be congruent, nor does it have to face the same direction to be considered a rigid motion. So again, the image is reversed here, but it is still a rigid motion. A glide reflection. A glide reflection is taking our translation that we did in the last section and a reflection that we just did in this section and doing them at the same time. So we talked about a composition of transformations in the last section. A glide reflection is a composition of transformations that does both a slide or a glide, which is doing a translation. And then from the translation, we're doing a reflection. So it's both a translation and a reflection. So you notice they're going from PQ to P prime Q prime, and then they're reflecting over the line to P double prime and Q double prime. An easy way to think of this is footprints in the sand. If you're taking a step on the beach, each footprint would look like a glide reflection of the previous. All right, so now on example 4, performing a glide reflection. So here we have a graph of ABC. Let's go ahead and see what the graph looks like. So we're going to plot points. Once we've plot those points, we're going to plot its image of a glide reflection. So first we are doing the translation, which is y of x minus 12, and a y which isn't changing, it's staying the same. So we're taking these and we're sliding them just to the left 12 units. So here's our original triangle. We're moving every single one of them 12 units to the left. So along the vector, 12 units long, exactly horizontal. So each one, again, just subtracting 12 from the original x values. So when you subtract 12 from 3, you got -9. When you subtract 12 from 6, you get -6. When you subtract 12 from 7, you get -5. So that's the first step. Once you complete the first step, then we're going to reflect it. So they want to reflect in the x-axis. When we reflect in the x-axis, the y value changes sign. So if we change the y value here, the 2 in the a prime will become negative, so it's going to be -9, -2. Sorry, yeah, -9, -2. Then our b value is at -6, 3 will now be at -6, -3. And then our c value that's at -5, 1 will be at -5, -1. So that's a double prime, b double prime, and c double prime. And we can draw our triangle. So we have our glide reflection, which again was a translation followed by a reflection. Now, did we actually have to graph this? No, if you know the properties from the last section and you know the properties from this section, you could do that without actually drawing the image. Now, this one did want you to do it by graphing. So again, we graphed it. However, if you just wanted to know what the final points were, we could have done that without graphing by following the same steps. All right, lines of symmetry. A figure in a plane has line symmetry when a figure can be mapped onto itself by reflection in a line. So that line is known as the line of symmetry. So on here, a trapezoid. This trapezoid does have a line of symmetry because if we drew a line down the middle, the left side would map onto its right side. A butterfly has line symmetry. It's identical on both sides. A regular hexagon has multiple lines of symmetry. This one has 6 different lines of symmetry through the segments and through the angles. So again, a total of 6 lines of symmetry can be drawn there. Then a parallelogram. A parallelogram does not, and they didn't show it, a parallelogram does not have a line of symmetry because the figure cannot be mapped onto itself by any reflection, no matter how you draw the line. All right, that is actually it for the notes. So again, I want you to do the lesson in class time, but this was the notes from section 4.2, reflections. Have a good day.